Assalamualaikum and salam sejahtera. My name is Mustafa Hazim bin Muhammad Razif and I'm from FTKE from BZ. So I would like to present my final year project PSM2, which is the development of an intelligent fire exit road system for the fast emergency evacuation in the building, or in short, e-FireExit. I would like to introduce my supervisor, Encik VIGNESWARA, anak lelaki GANNAPATHY. And I would like to address my panel and thank you for taking your time for watching this presentation, Dr. Hashima and Encik Ahmad Faiz. Okay, moving on. As you can see, here is my poster for PSM2. Okay, as far as the title for my PSM, the project description is: this project will enable survivors inside a building with a fire outbreak to escape safely with the use of the fire exit guidance system, where the system will determine the fastest route possible that the survivor can use to exit the building safely. Okay, for the problem statement of the project, Malaysia Fire Safety Protocol is very old and outdated in terms of technology advance. Malaysia High-Rise Fire Escape Protocol only consists of a map plan, and furthermore, the route of the map cannot be confirmed safe to be used in case of an emergency. This is a big problem for our safety protocol for Malaysia high-rise building. So my objective for the project is to develop a system that will help people evacuate a high-rise building safely with the use of modern route decision-making evacuation system to ensure the safety of the people. Next is to develop a new set of decision-making system without the help or input from human interaction where it can decide its own safe route. And lastly, for the objective is to develop a IoT-based alert authority system without the interaction or input from the human side. Okay, for my methodology, as you can see here on the left side, this is the block diagram for my project, which consists of an Arduino Mega as a microcontroller, MQ2 smoke sensor, and IR flame sensor as the two input for the system. And for the output of my project is the main component are LED strip, the buzzer, and the servo motor, which indicates for the LED strip is indication as guiding where the people or the survivor of the fire outbreak will follow the guideline and the line of the LED strips. As for the buzzer, it will imitate as a fire alarm to alert people inside the building. And for the servo motor, it will be an indication of a fire exit door that is locked if the route is not safe to be used, and people will have to divert into another exit. As you can see on the right side, which is my flowchart of the program, at the first, the Arduino Mega will initialize, will start, and then it will separate into two, which is the smoke sensor and the flame IR sensor. For the smoke sensor, it will first read the surrounding area, and it will ask if there is a smoke present. If no, it will continue on reading the surrounding. If yes, the buzzer will turn on, and then it will end. The indication for buzzer turn on is just a warning for the building tenant to check whether there is any possible fire outbreak. For the flame IR sensor, it will also do the same as the smoke sensor. It will read the surrounding first, and then if there is any fire, if there is no fire, then we keep on reading the surrounding. If there is the presence of fire, first of all, the buzzer will turn on, and after that, four of the LED strips will turn on to guide the survivor towards the exit, to the nearest exit. But if something were to occur at each of the point, let's say per se there's a fire in point 1, it will read the sensor will read if there is any fire. If yes, the LED strip will redirect the survivor towards point 2, which is we explained in the demonstration video. And after the LED have redirect the survivor towards point 2, the servo motor on point 1 will lock the door. But let's say if there is a fire on point 2, the LED strip will direct the survivor towards exit 1, and then servo will lock the door so that the door cannot be used and the route will be deemed unsafe. Same goes for point 3 and point 4. Point 3 is not safe, and the presence of fire is there. It will redirect the people from route 3 to route 4. Same goes for route 4. If there is fire in route 4, they will redirect it to route 3. And of course, both of the route, if there is any fire on each one of them, we lock the door and team cannot be used. For the result, this is the prototype. As you can see from the picture on the right side, there is 2 floors, and each floor consists of 2 LED strips on the right and on the left. This indicate on the left is point 1 for the second floor, and on the right side is the second point. This on the left side of the picture, you can see the result, which is where there is a fire in one of the point. The LED servo will lock the door, then the LED strip will redirect the person back towards another point. For my project features, the IR flame sensor can detect fire and decide whether the route is safe or not. When the IR flame sensor detects fire, the LED strip will act as the guidance for survivor to follow easily. Secondly, the MQ2 smoke sensor detects smoke present and give warning for potential fire. For novelty and inventiveness, which are in my project, are using IR flame sensor to determine if the route is safe or not. And the second one is the LED strip to guide the survivor to exit the building with ease and without confusion. Okay, as for my project, potential commercialization. I think this project is a potential commercialization for big company or apartment, which are both of them have big high-rise building, because it can save life of the occupant in the building if a fire outbreak were to occur. Because this system is very much suitable for a high-rise building. As a conclusion for my project, the main objective was able to be achieved through various research and study, which are the guiding system and the redirecting. During my period of PSM2, a lot of troubleshooting were to occur, but all of the during prototype, but all of the troubleshooting has been dealt with. But the troubleshooting consists of the LED strip, servo motor, and smoke sensor, where the main problem was the grounding, because of the unstable grounding, the prototype you can see on the right side does not give a very stable output, so that the troubleshooting has been done. Thirdly, for the conclusion is the Arduino Mega was not compatible with ESP8266 with Wi-Fi module to connect to the Blink application, where the IoT-based system was not having fulfilled. Okay. That's all from the poster presentation. Now we will be moving on towards the demonstration video. As you can see from the building, they have 2 strips of LED on the second floor and on the first floor, which indicates on the left side and the right side, which is point 1, point 2, point 3 and point 4. This is indication as is if a fire were to occur. the survivor have two choice of route that can follow, which is to the left or to the right, so that the survivor will not overcrowd one point in every floor, so that they can exit the building securely. For smoke detector simulation, I will be using this lighter, which will as indication for smoke for the smoke sensor. Here is the smoke sensor, which when detect smoke will turn on the buzzer for giving out warning. Okay, for the simulation of the guiding system, where the initial state is all of the LED is turned off and the buzzer is off, and also the servo is in off state. But we can see the light of the green light, which come from the IR frame sensor, which will always constantly read the surrounding area. So in order to activate the guided system, the main IR frame sensor, which is located here in front, will need to detect the fire present, and it will activate all the system. As you can see, the LED is turned on when fire is detected, and the servo will unlock the door, and the buzzer will turn on. As you can see, the LED immediate red and green light, so that the survivor need to follow the green light towards the exit and down the stairs, which where they have point 1, point 2, point number 3, and point number 4. And as you can see, the servo motor is unlocked, so that which means that the survivor can use the door to exit. In the previous video, we have seen the main system of the guidance, where when there is fire detection at the main IR frame sensor, all the LED will lead up and guide towards each of the exit. But if a fire were to occur at one of the points, the LED will guide back the survivor to another point and lock the door, so that the route cannot be used. As per demonstrate, this is when there is no fire detection at point 1 or 2, 3 and 4. But if fire were to detected at point 2, the LED will turn back the survivor towards point 1, and it will lock the door. Same goes for point 1. If fire were detected in point 1, it will lock the door and will guide back the survivor towards the second point. Same goes for point 3. If fire were detected at point 3, the LED will lock, the servo button will lock, and it will guide back towards point 4. Same goes for point 4. If you detect fire, the servo will lock the door and the LED will guide back towards point 3. Okay, this is all for me. Thank you very much.